Hello again. Look at here. I'm going to solve this example as application of the previous one. We have e to power 3x dx from 0 to ln of 2. So help me to actually, if you know how to solve that one, you don't need to study at home. So you have 3x dx. First of all, think about this example without boundaries. For example, think about such example like that. E to power 3x dx. We need what?
3.
Exactly. 3 and 1 over 3, you are right. Okay. Then I'll get what? I'll get 1 over 3 e to power 3x plus c. Am I right? Okay. Instead of c, we have what? You can see we have boundary, right? So I'm going to write boundary here again. And I'm going to write boundary here. Understood. And you know how to substitute these values. First of all, we have 3 ln of 2 minus 1 over 3 e to power 3 multiply 0. Am I right? And e to power 0 is equal to what? Number to power 0, number is equal to 1. So I'll get that one. I'll get 1 over 3 e to power 3 ln of 2 minus 1 over 3. Any question? And in your lecture, change it to ln of 8. I know, because he used that one as e, and I told you to not follow that one, actually. If you like it, you can do it, but our method is easier. It's more direct, more easy. Yeah. I didn't get your يعني بس شو لكن بوينتك هنا geçtim. ما بس area. Actually, here we are not going to use such function like that. But in Cal2, we have improper integrals. There, yes, we are using it, but not now. In Cal2, in the chapter 8 in this book, I think 8.6 or 7, we have an improper integral. تاوکاریکی نخوش ناتواو چون حلیکی ایتو بونه ایریا که کوتاینه آن لیوی باسیک. Yes, thank you. Question? Okay. How about that one? I will leave that one for you as a homework, okay? Yes. And we talk about that one, how to get it. Now we have properties. We have properties. Property of, we have 4 properties together. Look at here, properties. The first one is addition property. For example, we have e to power x1 multiply e to power x2 is equal to e to power x1 plus x2. The bases are equal. Kaka Muhammad, the bases are equal, so we are going to add exponential. Benchini Xana, Tuan Koken, appreciate it. Thank you. That's push. Okay, the bases are equal, we are going to add exponential. So how? For example, e to power sine of x multiply e to power x squared. In the case I say I have x squared plus sine x, or sine x plus x squared. Understood? Okay. Again, if I have what? Another property, the second property, we have e to power 1 over e to power x, he says is equal to e to power minus x. Means that if I have a exponent in the numerator, when I bring it up, I'll get negative. Example, e to power x squared. I say is equal to e to power minus x squared. Easy, right? You can play with it. The third one is depend on the second one. You say e to power x1 over, sorry. See what? e to power x1 over e to power x2, you see, is equal to x1 minus x2. Minus x2. Why? Because we know that one will come to up. Am I right? By the second property. Now we multiply by the first property, bases are equal. We are going to add the exponent. So I'll get what? E to power x1 minus e to power x2. Any question about the third? Easy, right? And we have what else? The other property? Yeah, exponential property, the multiplication of exponential. So we have e to power nm. You see m or you write r or x. You see, you will get e to power nm. What do you mean by that? For example, with a common mistake that the student in Calto will take it, will make it, sorry. So it's equal to what? Yeah, e to power 2x. Careful, is not equal to e to power x squared. Careful, okay? That one is not equal to e to power x squared. Careful, that's a big mistake. That's all I need to focus on. The same thing is true for a. What do you mean by a? For example, if I have 5 to power x multiply y, I say is equal to 5xy. Understood? Instead of y, write 3. You got the idea? The important thing is idea. So we multiply, we don't add them. That's the very important for you. And what else? Property the same property. Now you can see during the explanation of this lecture, I gave you A, but in your book, in the last one, will give you A. Okay, now you have all idea. So you know how to solve, how's the relation between them, you know. Also, you know how to find the derivative of them. Forget about this proof, you know, you don't need to. You know how to solve the derivative of them. The important things here is that example. I'm going to write, this is very important. Why is it important? Because tomorrow or next, lecture, Wednesday, you need give me 1 second, sorry. Now, here we are in this example. We are going to use that idea, the idea of this example during the solution for what? For L orbital 7.5. During that, because some types of the L orbital we need to take a ln. So that's why I say careful. Now here the example, we have what? We say if your function f of x or y equal to x to power x, careful, x to power x, function to power function, okay? Without x greater than 1, 0 or 1, then find what? Find y prime derivative df over dx is equal to what? Understood, Kaka? Okay. So in that case, we say what? How we solve that one? I'm going to the next page to have a good place. I cannot solve it directly, so I'm going to take a ln for both sides. So I say ln of y equal to ln of x to power x. You know, when you take a ln and you have an exponent, we say that again today, xa or xb or xy, we say is equal to r. We say is equal to r ln of x. Am I right? Okay, good. So ln of y is equal to x ln of x. Am I right? Now, derivative for both sides, the first line is equal to what? In 7.2, I gave you the clue of that. So derivative of the left side is equal to what? Yalla. Equal to 1 over y prime. Thank you. Derivative of ln of u generally is equal to 1 over u prime. Understood? But here this is the implicit function. That's why. How about the derivative of the right side? But do not say. Just raise your hand. Wait, Kak. Yalla. Right hand. Derivative. Right hand is equal to what? 3. Yes. أنا بيتناعوا هو يصيروا قدامها قلت ليش ما في بين يعني بيبقى شيء بس بيبقى لين اوف وات no what else any idea استعمالاتها idea كاكا يفر yes I like that yes you're right so first derivative of the second plus second derivative of the first f g. Understood? Do you remember? We have two functions x like x squared multiply sine. So how to solve that? Hello? You didn't get? Okay, I'll give you a box here. We have y equal to sine of x multiply x squared. So how we solve that one? How we find the derivative y prime? We say first derivative of the second plus second derivative of the first. Am I right? The same thing is true for here. If this is first function, that one's the second function. Yes, the same. Let b 1, let the exponent be sine. Okay, the same. When I took down, it will be the two functions. The first function is x, the second function is ln of x. Understood? You got it? Okay. Okay, now Now, 1 over y prime is equal to, you can see, 1 plus ln of x. Am I right? And we need y prime. So multiply both sides by y. Am I right, Jamaat? Good. So y is equal to what? Y. It was my question, y. My question was x to power x. Understood? So y is what? My example, it was like that. So y equal to x to power x. Understood? That's why I substituted here. Okay? Multiply by 1 plus ln of x. Then later you can multiply it or not. It's a simple way. How can you expect? Yes, give me. X ln x. How? آخر أول شيء هو أو a to power x. Careful. That one's different than that one. That one that you say is a to power x. Like what? Like 3 to power x. But now that number is x, means that change to the function. It's not constant. You are right. If it's a number, you are right. If it's not a number, you can't. You got the idea? Good question. Thank you. Any other question? Dears? Do you have a question? Okay. That one, listen, Kaka, I'm proving each. Forget about the proof. But that one, this formula, look at here. That formula. طبعا when limit of x approach to infinity. And that one is the same. You'll face that example in the 7.4, your duty. Careful. These are both, you can find them by using what? And approver is not included, but you can find them, this value by what? Sorry, by e to power is equal to e not e to power x. By what? By using L'Hospitals. So careful. Both are the same and you need to show them. So it's your duty. So your homework for next lecture. Maybe I'll ask you some question like that. I say how? Show me is equal to E. Okay? So careful, they are very important. And you know that about the derivative we say about that one? Do you remember that one? Hello? At the beginning of this lecture, we mentioned that one. Also, we mentioned that. Am I right? Yes, Kaka. Okay. Okay. For example, in Cal 2, chapter 10, section 1, we have a sequence here. We have that formula. For example, الرقم يكتبه الله ما كاتب e to power 2 أو هاي formula. Theorem كمان هي 10.1 the calculated Tomasa chapter 10 theorem number 5 مان هي last lecture كان أو شش formula مان هي شش formula أو شش same شوارم formula أنا أو formula أنا زور قرنج أنا ما بيزاني بس كم جاري اللي يرفير أبي how to prove it how to solve it then you will apply then اللي apply أكين جالا ما حبيت اللي لحاول point بينش خوب إحساس سعيد كردبي so you need to focus on it. This is the first. Did I answer your question? Okay, let me tell you about the history of that one. There's a German mathematician, the name is Euler. Euler. Do you heard about Euler? بخدمتنا جيشتون Euler? I'm going to share with you. Like a story خوش about research. That man. I know he lost his eye. After that on both eyes, but subtle is working without eyes. So they give the information. This E founded by Euler, the reference to that name, the first. After 10 years of the death, when he was dying, after 10 years, the students that they have, they want to clean the office. He found the Lin after 10 years when he died. So, and he lost the eyes. Without that one, without eyes, he can't solve the equations. So he found this E. So the formula that he counted, actually now you cannot even you count by the computers because E is irrational number, you know. E is irrational number, but he found it. I don't know how. Do not ask me because I don't know. So that's the formula of E. So it means that you will not get any number. any other numbers. This formula will just give you E. Understood? 2.7, something like that. That's about the history of E. Also history of Lin. That's why they are inverse to each other. E do زیبو publish کرد ولی لنکه دوای 10 سال. چون Lin نبود پیشتر. Log man have you have a log with exponent, for example, base of 2x, right? But he thought about log of ex. I told you during the Lin, right? So we say this one is equal to Lin of x. So that one published after 10 years. Understood, Kakijan? Is that? Okay, search. It was your question. It was interesting. So, you know, this one we talk about all these together. We have a, you can recheck the lecture. And we have that one. We see they are inverse to each other. Do you remember that? That's all about log. The important things here is that, okay, if you have log, okay, if you have log, how's the relation between log and Lin, and how we solve that example. That's very important. Understood, dears? So I have a log, how we find the derivative. We have a log, how we find the integral. It's very important for you. This example actually has many ideas, especially you have in your exercise, there's many type of that equation. So I'm going directly to that one to talk about the relation between E and Lin. First of all, if you have a log, you can, and you are not deal with it, especially for me, I'm not deal with that one. So you can find the relation between log and Lin. Look at here, Kaka. Look at here. Now I change log to Lin. This is the transformation or relation between log and Lin. How? If I have a log of x with the base a, I can write down like that: log Lin of a, Lin of x. I direct Lin. Understood? Hello? Why I am using this property? Because for solving such example like that, log of x2 over x dx, I cannot solve it directly by log. This is very important, careful. So how you solve that one? I'm going to use the property that I gave you right now. I'm going to change log, to x, sorry, Lin of x over Lin of 2 over x dx. Am I right? Wow. And I'm going to bring that one to out. And I'm going to write down like that. Understood? What did I do? Because I know this is A over B over C over D. D كم ليرة شنا؟ D كيرة؟ Day 1. Thank you. تدبيك ما نقلها. That's good. So this one will change to what? أقرأ ما يقبيه. A over B 1 over C. كواتا لني أو دو نمبرة. I can bring it to out, but I cannot touch the x. Am I right? That's why Lin of x and x remains. Question? Hello? Question? No. Good. So how we solve that one? A group packet plus 1. What did Okay. How we solve that this example? The section 1, I say plus 1. And some of them, they see something, I remember. Yalla. So how we solve that one? They خدها شيرين كان شتغلون هكذا ميان مين الحياة ما ناس يعني مش نازل يلا yes of course not to indirect حليكين. So what else? We cannot solve directly. So how we solve indirect? Let me give you some clue. I'll give you some clue, make it more easy. Actually, it's more easy. It's easier than the first step, the previous step, actually. Because now you can imagine. How? Okay. Uh-huh. Careful. If you have a multiplication, we cannot separate integral. Okay. Yalla. Discount 50%. Yalla. The first was 100%, now 50%. Yalla. 75%. Is equal to what? Easy? Is equal to what? You say easy. Yalla. No. Oh my goodness. You have a solution, I don't know how to read it. Yes. 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 Ln of x plus c. Am I right or not? Check. Maybe I did a mistake. Yes, we have a u du. Add exponent, divide by the new exponent. Am I right? But you didn't saw that one. That's why you didn't have a bit. Okay. Then like that. No. Tell me about that one. Sorry. I can't see your face. Yalla. You say it's equal to what? Right? Exactly. It's equal to sine square of x over 2 plus c. Am I right? How? You make that one u in your mind, and that one also du. The same. Understood? The same idea. Ln is like a sign, like a function. Now you can imagine it, right? That's good. So now solve that one for me. That's why I say it's very important. Solve that one for me. Yalla. Abi Nusum. Yalla. Is equal to what? 4 over 4. Easy, because now you can see what's going on. You separate it, you add it, that's why. So you have ln of 3, 1 over x dx. So in your mind, when you have ln of x, careful. When you have ln of x with 1 over x in the integral, so it means that you have u du. So I have a u and du. So that's why I write down like that. Ln of 4x over 4 plus c. I brought all these box for you to memorize it, to compare between the idea. That's actually it was the new idea. So okay, you don't know. But now, from now, for Cal 2, you need it. Understood, Kaka? Hello? Babam Dada. Dada Kanish. Understood? Good. So that's the end of the section. Thank you for being here.